So if you are also get confused that why there are so many Reynolds number and why I am getting so many ranges for different type of regions, like turbulent, for turbulent I am getting sometimes the range is less than 2100, sometimes I am getting the range is less than 5 into 10 to the power 5. So why this is happening, why there are so many Reynolds number and so many values? So for clearing this doubt, I am making this video. So there are not so many Reynolds number, there are only two Reynolds number mainly. And on the basis of the characteristics of Reynolds number, we are going to understand that why there are two Reynolds number. Okay, so let me clear the screen and I will show you, and be with me. So first of all, Reynolds number is depends on the characteristic of fluid, right? And second, it depends on fluid dynamics of the fluid, right? So on these two things the Reynolds number depends. So fluid characteristic of fluid, if you are taking one fluid always, it is going to be same. But when it comes to fluid dynamics, there are some problems, because dynamics will change when you are going to change the flow type. So let's see how this is going to change the different, how we are going to get different fluid dynamics and different Reynolds number. So suppose we are flowing a fluid on a surface. We are flowing a fluid on a surface. Suppose this is case 1, and we are talking about this fluid dynamics only. So this is case 1. Case 1, fluid on surface, right? So this is my surface, and the fluid is flowing on the surface. So first of all, the fluid getting no any friction from the surface. Now as it enters the surface, it is going to get friction from the surface, and the region is going to be like this. The boundary layer is going to be like this, because at this point you can visualize that the velocity is going to be 0. Why? Because the fluid is in direct contact with the surface, and if fluid is direct contact with the surface, the relative velocity is going to be 0. And at the highest point, the has the highest value, means the free stream velocity, right? So the boundary layer is going to be, profile is going to be like this, right? Easy. And in case 2, the fluid is in pipe, right? So we are taking a pipe, we have a pipe, and the fluid is flowing like this inside the pipe, just entering in the pipe. And as it go in the pipe, the profile is going to be like this. Why this? Because at this point the velocity is going to be 0, because it is in contact with the surface, and the fluid is in contact with the surface. Here it also the same scenario, and at the middle it is going to be maximum, right? So we are going to get this type of profile. Now you can see that in both the case the fluid dynamics is different inside a pipe and on the surface when fluid is flowing. Because of this, there are two type of Reynolds number. When in case 1 the fluid is flowing on the surface and the fluid is flowing on the pipe, has different Reynolds number. So I am going to write it as a green Reynolds number, green color, this Reynolds number. And this Reynolds number that I am getting on the flow on the surface is, I am writing it with blue color. Okay, so there is two Reynolds number we are going to get, right? So now I am going to see that what are the different ranges that we are going to get for this two different Reynolds number. So first of all, I am writing the turbulent transition. First of all, let's write laminar. What is for laminar? For laminar, for transition state, and for turbulent. For turbulent, right? So for laminar, it is going to be for this for Reynolds number on the surface, it is going to be less than 5 into 10 to the power 5, and for turbulent it is going to be between 5 into 10 to the power 5 and 10 to the power 6, and for turbulent it is going to be greater than 10 to the power 6, right? Easy. And for this Reynolds number, the laminar region we are going to get in less than 2100, means 2100 value. If the Reynolds number has value 2100, less than 2100, right? For a transitional state, the value must be between 2100 and 4000, and for turbulent region the value must be greater than 4000. So this is the two different region that we are going to, and value we are going to get for different region for different two different Reynolds number, right? And now we are going to see again the basic difference in the formula for this two Reynolds number. So first of all, the first difference you are going to get is for this Reynolds number. For this Reynolds, let me clear this dot from the picture or diagram that I have made. For this Reynolds number, this blue Reynolds number, your formula is going to be rho u infinity and x by mu. Okay, this you are going to get here. And for this Reynolds number, you are going to get the formula rho u d by mu. So rho and mu is common. Then why we are going to get a difference here? Why there is a difference here in u, and here it is x, here it is this u and d. So that u infinity is the free stream velocity. Free stream velocity, that is this free stream velocity, and the x is the length on the fluid is flowing. X is the length on which the fluid is flowing, and that we can call as distance from leading edge. Distance from leading edge, right? And here in this part we are going to get the value as u. So this is average velocity of the fluid inside the pipe, and this d is characteristic diameter, right? The diameter of the pipe, characteristic diameter of the pipe. Okay, so this is the thing, this is the difference between these two Reynolds number. Here the average velocity you are going to get as because you have to take the average velocity of the inside pipe, and this diameter, length and x, it is the characteristic distance that is going to influence the fluid flow, right? So these are the two difference that you will get. You can see the formula, difference in the formula for this two Reynolds number, as well as the value of ranges that you are going to get, different value for the different ranges you are going to get for this two Reynolds number, right? I hope this will clear your doubt. Okay.